have 4x y to the power of negative 2, all to the power of negative 3. So there's a few ways you can deal with operation or exponents sometimes. I could apply the negative 3 to each factor inside the brackets, or I could get rid of that negative right away. Okay, so I could turn this into 1 over 4x y to the power of negative 2 to the power of positive 3. You only change the outside exponent.
Does it matter which way you do it?
No. I'm going to show both. Okay, then I would have to apply the cube to the 4, to the x, and to the y to the power of negative 2. So 4 cubed, what do we get? 64. Okay, then x cubed, and then y to the power of negative 2 to the power of 3. You multiply, so you get y to the power of negative 6. Negative 6. We need to get rid of that negative exponent. So in the denominator, we still have 64. We still have x cubed, but we need to move that y to the power of negative 6. We're going to move it up to the numerator and make it positive. So that was method number 1. I'll show you method number 2. Okay, method number 2 is taking that outside exponent and you're applying it to every factor inside the brackets. Okay, so we have 4 to the power of negative 3. We have x to the power of negative 3. And we have y to the power of negative 2 to the power of negative 3. From there, to change these to positive exponents, we have to move them to the denominator. So we get 4 to the power of 3, which is 64, so I could just write that right away. Okay, x to the power of negative 3, if we move that to the denominator, we get x to the power of positive 3. And then lastly, in the numerator, we have negative 2 times negative 3 is y to the power of positive 6. Okay, it looks like the same amount of steps to me, so it just depends which technique you like better. So having seen both, hopefully you guys have some space to try B on your own. Okay, and then we'll go through it as a class. So probably what I would do, just as an introduction to this type of question, is I would apply 3x cubed and then apply that negative 2 exponent on the numerator as a separate exponent. And then I'm going to apply it to the denominator as a separate exponent. Seeing it individually, you guys probably can see now that if I just flip them, the exponents will be positive. Can you guys see that? Okay, so 4y to the power of negative 2 will go to the numerator, and now it's to the power of positive 2. Okay, and then 3x cubed will go to the denominator, and the negative 2 exponent will now be positive 2. Okay, rather than writing this out separately like this, what's happened with the fraction inside? A little louder. Okay, what's happened from here to here? It's switched. So rather than doing this step, what could we do automatically? Okay, next time we'd be able to do that. Okay, we'll test it. Okay, so now I just apply the exponent through. Okay, 4 squared, I get 16. Y to the power of negative 2 to the power of 2. We multiply those exponents, so I get y to the power of negative 4. And in the denominator, 3 squared is 9. X cubed squared is x to the power of 6. One last change. we gotta move that y to the power of -4 down to the denominator. So we get 16 over 9x to the power of 6, y to the power of 4. If and when possible, if you can reduce your fraction, put that to lowest terms. In this case, can we reduce 16 over 9?
Yes.
What can you take out? It looks like you would be, but you can't. Okay, so 16 over 9 is as low as it can go. Alright, next one we're just going to look at a few questions. We're not allowed to use our calculator. So we're going to evaluate to exact form without a calculator. Okay, so if we change this so we have a positive exponent, we get 1 over 2 to the power of 3. And 2 to the power of 3. 2 times 2 is 4, times 2 is 8. So we get 1 over 8. Next one, we have 81 to the power of 3/4. The easier way to evaluate this without using our calculator is to apply the last law we learned. So 81 is my base. Do you guys remember what the denominator would become? The index. So we're going to take the 4th root of 81, and then we're going to put it all to the power of 3, which came from the numerator in the exponent. The 4th root of 81, which you will probably learn with practice, okay, just by figuring out, well, if I multiply 3 times 3 times 3 times 3, do I get 81? Okay, 3 times 3 is 9. 9 times 3 is 27. 27 times 3, you do get 81. Okay, so the 4th root of 81 is 3, and then I have to cube it. So 3 cubed is 27. One thing we didn't talk about, this is review again from grade 10. Anything to the power of 0 is what?
1.
1. You guys are awesome. Okay, anything to the power of 0 is 1. Okay, this next one's a little bit unique. First thing, let's deal with that negative exponent. So we're going to write it as 1 over 16 to the power of a half. Another way of writing 16 to the power of a half is writing as, remember, the denominator in the exponent would be the index of the radical. So you're taking the square root of 16. We have 1 over 4. Okay, I'm just going to test you guys a little bit. What do I want to do? Sure. Okay, how could I rewrite this? 7 times 5?
Or 7 to the
power
5.
of 5. Good. So what does the 2 tell me? Square root. Good. What does the 5 tell you? Power of 5. So if I just simplify this, we get 7 to the power of 5. I have to do a little bit of math to figure out what it is. But I just wanted to make sure you guys knew how to go from a fractional exponent to the radical.